everyone. Today we would be learning about simple machines and how they help us with our everyday tasks and making our lives just a little bit easier. So the first thing I would do is hand out the sheet I made that lets the students make their predictions on what simple machines are, how they help us, if they've seen any, just kind of get their minds flowing. The second thing would be this video. I did make it into a video. You can also have it as a PowerPoint, but I'm just going to pause it whenever I need to talk. There it goes. I know it's backwards, but it's okay. The video is linked in the lesson plan. So the first thing, the first thing is, do you know that simple machines help make our life easier with everyday tasks? Well, what is a simple machine? A simple machine, they're fundamental devices with few or no moving parts that help us perform everyday tasks more efficiently by altering the direction or magnitude of a force. And we're going to find out what a few simple machines are. So our first simple machine is going to be a screw. And as we can see here, screws are simple rods with edges around a pole. I do have two examples of a screw. I could find these. I have two different ones. This one's a longer one. So this screw, like you can see, it's like a straight line of pole. And then it has these little edges. I think you'll be able to see it better on this one. Yeah. You have the little edges around it, and that's what helps it go into the wall. Or if you're hanging something, a lot of people use screws to hold things together. But they make our life easier. They're just, depends on, there's all kinds of different sizes. But you can see here are the ridges. And if you've ever seen one go in, it just screws itself into a wall just like that. And that's where it comes from. I can't make it screw. But this is a screw. And we see the little edges right there. And that's what helps it go into things and hold things and makes things secure. So that is our first example, a screw. There it goes. And then a lever. So what is a lever? A lever is a device that rests on a fixed point. I couldn't find an example of this laying around, but it is used to move or lift different loads. So as we can see here, I'm going to move the camera just a little bit. There we go. So a lever, this is the fixed point. And you can see there is this long, on here you can't really tell what it is, but it's like a long piece of wood, this one is, and you can use it to, like it said, lift loads or move loads. So all the weight's down here and we're moving it to that side, or some people use a lever like a wheelbarrow. There's many different levers out there that we didn't even know were levers. We're going to go to the next one, and that is a wheel and axle. Now this one is probably my favorite one, and I hate that you can't really see the words on here, but you can kind of see the picture right here, and you can see it moving right there to kind of see what that is. And a wheel and axle is a simple tool that helps make work easier. The wheel turns around an object or around the axle to move objects. So some examples of wheel and axles would be like a toy car. You have your two wheels, and then the axle is the thing that holds them together, and they spin as the toy car moves or as your parents' car move. That is a really good example of a wheel and axle. Our next one, there we go. Our next one is a pulley, and you can kind of see in the little graphic right here, a pulley. A pulley is a tool with a wheel and a rope. Wheel, and then the rope. It is used to lift or move loads. So again, a pulley, I know a lot of times in your shows that you watch at home, sometimes they'll have a really cool tree house, but how do they get stuff up there? A lot of times you'll see them make their own pulley, and the pulley will lift things off the ground and take it up to their tree house, or they'll have stuff in their tree house that they need to get down that's really heavy, or they can't climb up the tree with them holding it. So a lot of times they'll use pulleys to set whatever they need to get up there or down, and they'll lift it up and it'll go back down, all because of the rope and the little wheel right there. So that is a pulley. And then the next one is a wedge. I did it again. A wedge, and you can kind of see in the graphic how a wedge works. But a wedge is a tool that narrows to a thin edge. An axe is an example of a wedge. So if you've ever used, or door stopper, if you look around in the classrooms, a lot of teachers have door stoppers so their doors will stay open, and that is an example of a wedge as well. So wedge, I do have this one that's kind of shaped like a wedge, is thicker on one side and then flat on the other side, and it goes into something to kind of stop or hold it. A lot of people use them for doors, like they call them door stoppers, and then that is just a simple machine that is a wedge. I think there may be one more, or is that it? Okay, yep. Our incline plane. So an incline plane is a tool with a flat surface. So again, kind of like a wedge, but it is elevated at one end. An example of an inclined plane is a ramp. So if you ever, don't go up the stairs, but you still need to get up, you see a lot of people sometimes with wheelchairs, or sometimes they'll have like bike ramps, and they literally look just like this. And they could be cement. They could be a foam if you do gymnastics. I know when I did, we called this a cheese. I don't know if they still do anymore. But that is an inclined plane because you start at one end and it gets lower on the other end. A lot of times people use them to move things. It's a lot easier. It's kind of like a slide for your objects if you want to move something. And that is the inclined plane. You can kind of see it again right there. That is the inclined plane. All right, so now that we're done with the video, I'm gonna get off of that. There we go. Okay, so now that we're done with the video, I would just kind of reiterate what simple machines are and how they help us in our everyday task. Explain again what we saw in the video, and that was the levers, pulleys, wedges, incline planes, screws, and wheel and axles, or wheels and axle. They make our work easier. After we watch the video and after we watch the video and kind of go over what they are again, then we would start with the activity, and we would need a lever. We would use all the simple machines to kind of see how they work, but we would need a lever, a pulley, an inclined plane, a wedge, a screw, and a wheel and axle. So I do have those listed of the examples that we could use. And so like the lever, we would place the ruler on the pencil and balance it, or place a small object on top of it like an eraser, and then apply force on the other end and kind of see how it works. So I'd get each of my students to do that, and we'd all get a good understanding of how a lever works. And then we would go back to our sheet and record the effort we needed to lift the object. And on the sheet, takes a second to pull it back up. Okay, so there is the data table, and that would be as complete as you go. And then after we do the lever, we write down the task we did. So the task would be that we had a ruler, we balanced it on a pencil, and then we put the eraser on there. And then the observation is, how much force did we need to move the thing? Would it be easier that way to use the lever, or would it be easier to just move it by ourselves, something like that? And then after the lever, we would go to the pulley. I have the pulley next. And then this one I thought was really cool. We would thread the string through the spool and attach a weight to the end. Now I'd probably have to I couldn't find how many ever kid weights for each kid, so we'd probably have to do it as a class demonstration or a few weights passed out, and they can get into groups. But we'd pull the string to lift the weight, so kind of remembering what we saw in the video with the wheel, and then we pull the string up to lift the weight just like the pulley did, and then record again the effort we needed to lift the weight, which would be the task, and then what we observed. And then for the inclined plane, we would set up a board on a stack of books to create a slope. So a stack of books and then a board. Again, I think this one would be a class one. And then we would roll an object, either a car or like anything, like a ball, like any like kind of toy we had or something that could roll down, and that would be our inclined plane. We would again record the effort needed, just a simple push to move the object, and then we would write our observation down. Like, it was much easier to use an inclined plane because all we had to do was a simple push to get it across. I did put those answers though in the student worksheet. And next we would do a wedge, and now the wedge is the door stop that I talked about as an example in the video. To keep the door open, we would push the door stop under the door. We would observe the effort needed to just push that instead of having to hold the door. I'd come let the kids try it, like how long could they hold the door versus the door stop, could it do it all day long. And after they recorded their observations, we would go to the screw and we would close a jar lid. So this is a different example of a screw to kind of show them that there are more than just the simple screws that we showed in the video. But we would have like a pickle jar lid or some kind of jar, olives jar like that. And then we would close the jar lid and then observe the effort needed to twist the lid. I do think it gets easier after you twist it many times. So they would all take turns trying to open the jar lid and record their observations on that one as well. And then the last one is the wheel and axle. We would use the same car toy from the previous experiment, and we would roll the car toy on different surfaces, and we would observe the effort needed to move the car. And on that one, I would tell them without the wheel and axle, how would a car go? I would ask questions like that to kind of get their brains thinking. Why wouldn't the car go if it didn't have the wheels? Why wouldn't a wheelbarrow go if it didn't have the wheel? Because everything with a wheel has to have an axle. And again, we would record our observations and write down if they put the toy car on grass, if they put it on concrete, if they did it in the classroom. And then after completing the experiment, I would have them answer the rest of the questions on the worksheet. And the rest of the questions are, how did the lever make lifting the eraser easier? So the lever and the eraser one, going back to that one, this would be after they have completed all of the experiments. And then to explain why using a pulley requires less effort to lift a weight. How does an inclined plane reduce the effort needed to move an object? And describe a wedge. How a wedge works to hold a door open. Why is it easier to move a car with wheel and an axle than without? And then after they complete that, I would go back over what a screw is, what all the simple machines are, and answer any questions and make sure they get the concept. And that would be it.